For this problem, we'll use the following formulas. The first formula is delta f equals to the function evaluated to the second x minus the same function evaluated to the first x. For the second formula, which is the formula of surface area of a sphere, equals to 4p times radius squared. For the third formula, we have the derivative, which equals to n times x elevated to n minus 1. The n equals to the number of the exponent. And the fourth formula is delta y equals to the derivative, which is the formula from the above, times dx. The part A of the problem, we will use formula 1 and formula 2. We will be our surface area formula.
Now that we establish which formulas we need to get, we plot our values in our x's. x1 equals 20 and x2 equals 21. Therefore, we use the first formula, delta f, but now we can plot our values. So we can write 4 pi multiplied by 21 to the second power minus 4 pi multiplied by 20 to the second power. After we plot our values in the calculator, we can get that the answer for 4 pi multiplied by 21 squared is 1764 pi. 4 pi multiplied by 20 to the squared power on the calculator. Then we can get that the answer will be 1600 pi. We subtract both values in the calculator and we can get that the final answer is 164 pi, which is equal to 515.22. But the problems say that we run to the nearest integer, so we leave the answer as 515.
For the part B of this problem, we're going to have to use the formula of the surface area. But in this case, we are going to need to derive this. So, we're going to have to use the formula number 3. If we derivate this, we're going to have to multiply the exponent, which will give us 8 pi radius. Also subtract 1 to the exponent, but as it becomes 1, we don't write anything.
On what formula of the derivative, we'll replace our values in the formula that we got. Then we'll use the formula number 4 in order to continue with the procedure of the final answer. So we plot first the formula of the derivative of the surface area and we evaluate it in our x1, in this case 20. Then we need to establish that our dx will be x2 minus x1, which is equal to 1. Then we multiply this and we get the final value, which will be the approximate change in the surface area. The final answer is 503, and since it's also area, the units in this case centimeters are squared.